Our first speaker in this block on digital economies is Nicole, VP of Darktrace. Nicole.
Hello, thank you for having me. I'm very excited to be celebrating International Women's Day with such an incredible, esteemed group of colleagues. It's good for the soul. It's just an amazing, uplifting experience. So I very much appreciate it. Darktrace is a cybersecurity company, but it's an AI company applied to cybersecurity. I love speaking with data scientists because you guys are what's critical to the safe adoption of AI as well as AI security. I'm going to paint the stage for you. About 18 months ago, ChatGPT hit the scene and generative AI kind of exploded. Unfortunately, it was released into the wild with no data integrity and very little security in place. This is where the people in this room are critical to the safe adoption of AI. Data integrity is really what drives the accuracy of machine learning models, and data science is what really drives data integrity and testing, evaluation, and validation processes. This is a critical part to the safe adoption of AI, as well as when we apply AI to security. So these models hit the scene, adversaries immediately jumped on it and started innovating with gusto. We saw prompt-based injection of large language models. They were able to take over these models. They created autonomous agents that were large language model based. That's where we saw the explosion of AutoGPT, HackGPT, FraudGPT, WormGPT. These autonomous agents at its current state is kind of in its infancy. The decision-making quality is not that great yet, but with well-funded and well-resourced threat adversary groups, we expect better multi-hop reasoning and better complex decision-making of these autonomous agents, and we have to be prepared for this scene. Also, we saw inadvertent insider threats. Well-intentioned employees wanting to experience with a new technology, inadvertently exposing company-sensitive data to underlying models. This is where groups like this are critical to the adoption of AI, not only safely, but building up the trust that's needed to apply these AI models effectively. Good news is, as adversaries are already innovating with AI, so are security teams. Many cybersecurity companies have been innovating with machine learning models for almost 2 decades now. Most of my career has been in the cross-section of AI with cybersecurity. The important thing here, though, is that we need to innovate at the speed, if not better, than the adversaries. If they're going to start relying on autonomous agents to augment their attacks on demand, we need to be able to respond in machine speed and scale so that we can contain incidents, mitigate risk and damage, and buy human defenders more time to come in and perform a more complete investigation and remediation. But how do we do that? How do we depend on autonomous agents? We have to build up a trust relationship with the AI that backs it. The only way we can do that is with data science. The only way we can do that is with establishing good foundation principles for the data integrity of the models that it's trained on or it's continuously learning on, and that we're setting up good accuracy benchmarks for testing, evaluation, and validation process. You guys are critical to adopting AI when it comes to building up the trust relationship, ensuring the AI systems are privacy preserving, they're accurate, they're explainable, and they're transparent. All of that is data science. So Darktrace, that's the company I work for. We started off as an AI research and development center out of the University of Cambridge almost 11 years ago. We're founded by mathematicians and cyber defense experts who really wanted to take a totally different, novel approach to machine learning than what the rest of us were doing in industry. I include me in that picture. Most of the rest of the industry was working on big data tropes, historic reported attack trends so that we could apply probabilistic predictive modeling as well as classifying modeling at scale to process and try to detect malicious activity at the get-go. Darktrace totally took a different approach. They're like, we want to learn an organization to its completest extent. We want to understand every asset within their digital state, how they interrelate with one another, how they behave in a normal capacity, what is their pattern of life, and then identify the true anomaly. Find the misuses and the abuses, both internal and external, as well as those misconfigurations that can cause bigger security problems down the road. That's why I was kind of excited to join a totally different approach, which is unsupervised machine learning, trying to make hundreds of thousands of micro decisions to get insight and intelligence of data itself to facilitate the quicker detection and, as we'll talk about, response. Oh goodness, I have to do a lot of clicking. So in our approach here, we call our unsupervised machine learning engine. It uses about 24 different types of machine learning techniques and dozens of different models. We want to ingest the raw data from as much different domains as possible: IT, OT, network, endpoint, cloud, SaaS. We want to understand every asset for an organization. We use graph theory to understand the complex, intricate relationships between people, processes, technology, and systems. We use collaborative and combative clustering algorithms to understand how an asset operates compared to the other assets. We apply Bayesian probabilistic modeling across all of those different detector models and clustering models to perform the continuous learning. It's not static, it's not pre-trained. Organizations are dynamic, they change over time. Your machine learning needs to change with it. So we're allowed to use, we can use Bayesian probabilistic modeling to take in posterior or historic information as well as current information, and then apply probabilistic modeling as a result on top of that to truly identify those anomalies. We use deep neural networks and supervised machine learning to mimic cybersecurity investigations. I'll get in that in more detail. And again, we're really highlighting the anomalies. We're not looking for signature or rules-based or IOC-based detection, because that's going to become obsolete with tools like AI. It's so easy to change the signature of a malicious script. It's so easy to change their IOCs now. They're building out infrastructure that's automating the threat adversaries landscape. So we need to be able to be as dynamic and identify the unknown unknowns, the unreported, what's truly anomalous to a specific organization. And we use natural language processing in order to provide the explainability and transparency of the end-to-end investigations, as well as confidence solicitation, because you cannot operationalize data without understanding its value. So we use that to show risk and rare scores. And I kind of jumped too soon, but really quickly at the end we said post-processing and unsupervised machine learning. Obviously humans are inherently out of the loop, but critical to the control and post-processing and operationalization of machine learning. That's where data scientists need to be able to perform that exhaustive TEVV process, as well as control the post-processing and the operationalization of that data. So I'm going to give you a quick case study. Purple Fox is a very tricky, versatile, dynamic rootkit that is very persistent within organizations and very hard to detect. In this particular case, we saw a healthcare industry client, obviously critical customer, critical community that they serve. Malware attacks are very detrimental to those types of environments. And we noticed in the very earliest stages of the kill chain, a host had been infected. There was a control request to go out to an additional host of servers to download a malicious PNG. So we kicked off an autonomous investigation. Our cyber AI analyst, which is trained on 5 years of our own Darktrace security investigation analysts, as well as using neural networks to be able to pull together a whole bunch of low-level events of anomalies across different model breaches that can provide an end-to-end investigation as to how that can all be related. As a result, we started seeing a whole bunch of internal network reconnaissance scanning. So we're already now seeing the early steps of setting up, if you download an additional ransomware, how does it spread? How does it move laterally throughout the organization? So these could look like two totally different anomalous isolated events, but we use supervised machine learning and neural networks to pull all of that information together and show a more complete picture within the organization. But our autonomous response agent was put in human confirmation mode. So we alerted them. We said, hey, block this download of this malicious PNG, cut it off as quickly as possible, and they weren't able to. So it's important to build out that trust with these autonomous agents, and that's where data science comes in. You can only build out trust with AI when it's explainable, it's transparent, it's gone through ethical practices, it's gone through data integrity, it's really, we show the value of data through data science, but we show the value of AI through data and through data science. And that's all necessary to build that trusting relationship with AI and to be able to respond quickly in machine speed in a very dynamic threat landscape.